So like I said, we have different types of solar panels. So the solar panel we have the monocrystalline, polycrystalline, then we have the thin film. So these panels are graded according to their composition and according to how effective they are. This is less effective and the efficiency of this is very poor. So that is why over time, when you ask people the types of solar panel we have, they will boldly mention these two, making these two popular than the other. So, but here now you see we have the monocrystalline and the polycrystalline. The monocrystalline is very effective compared to this. Then it also has what we call space efficiency. Because of these two factors, it doesn't depend much on the appearance or the intensity of the sun for it to function. Because of that, it is more expensive compared to polycrystalline. So monocrystalline is more efficient, more effective, and also costs more in terms of its costing during production and also during sales. The cost of this is higher than this. So because of that, this is mostly used because of its efficiency. So depending on the locations. So these are the two major ones that is popularly known, but we have three types of solar panels. So I've been able to establish this fact. Knowing this will help us to know that you cannot combine monocrystalline with polycrystalline at the same time. You can't combine two of them when running the connection. So as you cannot combine that, the same way that you're not going to combine different capacities of solar panel together. Why is it not done? Why? What happened? Why won't it work when it is being combined? Yes, in terms of electricity, we know that we have policies, we have basically the connections we use, which is parallel and series connection. But no matter the connection you are using, either series or series parallel or parallel series, anyone you choose to use, you must ensure that different sizes of solar panels are not integrated together in one system. For instance, we have a solar panel of 12 watts, 24 volts, and we have another one of 30 watts, 24 volts. Some people will ask why, but they have the same voltages. Why can't we just combine it? Okay, so this is the major reason why the system is going to fail. If you eventually combine this, the system will definitely not give you what you need because you are not following the rules or the principles that guides these connections. So for us to generate, let's say we need 30 amps or 30 watts of energy, and we have 12 and we have 30. So if we combine this in our normal sense of reasoning, you can just say if we add 12 plus 30, it should give us 42. But this is far wrong. It doesn't hold. So the rules of this is that the moment you connect a high wattage to a lower wattage, what will happen is that the lesser one will take advantage of the high ones and drop it to the size of the small one. Get it right. When you connect 12 watts with 30 watts together, what the connection will just do is this will definitely drop this size and give you the output of what? 12 watts. making this high size of panel useless here. It doesn't contribute anything to the system again because this has taken the power. The rules means the lesser we take advantage of the higher one, which is the opposite of our normal thought. So whenever you are running your connection, if you have the same thing happens to our battery connections, for instance, we are trying to generate in our battery, you have 200 amps, then you have 100 amps battery as well. And you are trying to maintain 200 amps or 300 amps. So you said, okay, let me now connect this and this in series. The moment you do, this is your battery. Positive, negative, positive, negative, positive, negative, positive, negative. So this is 200 amps, 100 amps. So, and you are trying to connect them in series. So after getting your parallel connection on this, probably you want to run your parallel connection here. And this is here. So you actually know that if you do parallel connection, your output is going to be the same 400. 400 amps when we do the parallel connection. So because the voltage will remain the same thing, which is 12 volts, 12 volts. So now here we did the connection of another parallel connection here, positive to the positive and negative to the negative. Then we are left with 200 amps. Now, because we've been able to generate 400 amps here and 200 amps here now, you now say, let's combine it to get 600 watts. And in doing so, you think you are going to get 600 watts, but the fact remains that you are not going to get 600 watts. Instead of having 600 amps, rather, you are going to have 200 amps the moment you run your connections. So why is it so? The lesser will take advantage of the bigger one and drop it to its own capacity, because you cannot, if this is what this thing will, you see the ink inside this thing, inside the marker, you cannot fill it above the container. The rest will become a waste. For instance, we have something here. Let's assume this is our battery and we have the space for the cells inside. So if you are trying to fill in the amperage, which is the current inside, it cannot exceed the container. If you fill it above, the rest of it will become a waste. It can only collect the size that it can hold. It can only maintain the size which it has been designed to hold. So the same thing happens here. So if you are doing it like this and you are putting higher amperage on this, what it means is that the moment it gets the size of this, the other ones that are coming in are waste. So the same thing happens here when you have your system. This is our system now. When I'm talking about the system, I'm talking about the solar system itself, which is the inverter and the load, all of them together. So when we have something like that and you are trying to combine 200 with 400, what will happen? This is the size that comes out. When you are trying to feed this and this, the connection of 200 amps will drop this capacity of 400 to its own normal size that it can hold. So if you combine this and this, you are going to have 200 amps. Whether you like it or not, this is what it will give you, 200 amps, because So in the same way, in your panel, if we have a panel of solar panel of 3000 watts, okay, let's use 150 watts here. Okay, 150 watts and 300 watts. So our 150 watts will give us, have the tendency of generating 3 to 6 amps, and our 300 watts has the capacity of generating 5 to 9.5 amps. If we say okay, because we need higher amperage and we have 150 and we have 300, that we are trying to get like 10 or 11 amps, and you decide to combine this and this, it will not hold. What it will give you is that the amperage of this 150 will drop the amperage of 300, which will make your system only to pass out either 3 to 6 amps, as the case may be. Sorry for the marker. Understand, to pass out 3 to 6 ampere. Why? Because you combined the lower size of panel with the higher size. So for your system to work effectively, they must be in the same amperage rating. Amperage rating. Amperage rating, meaning you must have, if it is 200 watts that you are using, you are going to combine it with another 200 watts. Then if you choose to use 150, you continue with 150. If you choose 300, you continue with 300. If you choose 1000 watts, you continue with 1000 watts. You are not allowed in the course of connections or in the course of installation to combine 300 with 200 or combine this with this at a straight connection. So the only thing that can be done during connection is probably in the practical settings. You have this, you have 150 watts of 2 pieces, and 150 is 12 volts, and you have probably 300 watts, which is 24 volts, 1 piece. So what do you think that is going to happen? If you say you are running 12 volts by 12 volts, which will give you 24 volts. This is nice, right? Okay, but I prove it to you that this connection will still affect your system, because when you do this, this is 7 ampere. This is 7 ampere per one. So when you are doing series connection, what happens? During series connections, the voltage increases while the current remains the same. Let me prove it to you. During the course of connections, you have 12 plus 12, which is 24 volts. But the amperage of the two panels will not change. It will still give you 7 ampere. Then you have 300 watts, which is already rated 9 ampere. If you now, because you said this is 24 volts and this is 24 volts, and you want to combine it because that 24 volts, 24 volts, what will happen is this: when you get this, and this, because they are parallel, they will come at a point. That's what we call a node. A node is the point of connections. Point of connection is what we call node. Node, node. So this, the rule that says the amount of current that flows in is equal to the amount of current that does what, that leaves the node. When you do Boyle's equations or Kirchhoff's law of electricity, you find out this. So from here, you see that what this one brings in, they are now acting as a separate entity. They are not combined. That is why if you do it like this, it will still function. But when you run it with series connection again, it will drop the amperage of this 300. But with this thing, you've gotten this in series and you're now trying to combine it in parallel connection. What it means is that this serves as its own, comes like this, come here, and this one will come bring it on here. So whatever thing that we're taking out is what comes to this particular node. That is to say, when it comes, the 150 watts two that is combined will come and drop their own. Their 7 amps is here. This one will bring their own 9 amps. There will be a slight increase that will make the system to function, because the 7 is coming on its own and the 9 is coming on its own, and because of that they are generating 7 plus 9, which is 16 ampere, which will make your system to be more effective. But if you do it otherwise, by saying let me now do it series connection, by bringing out your 9 ampere and bringing 7 ampere, remember, if you combine it, the 48 volt will hold, but the amperage will drop. So this is how it works with your solar panel. So it is not proper for you to run connections of panels with different size of panels, different current rating, different voltages, different wattages, which is the power rating of the solar panel. So when you are running your combinations of panels, the first thing you consider is what are their sizes. What are their sizes? Sizes in terms of the dimensions, which is the physical appearance, the length, where they can stay. Then, but the core fact is about the power, and the power include both the current and the voltages. So you must put it in consideration whenever you are selecting the size of panel to be combined. So with these points, I know a lot of value has been shared here, and I know you understand the information properly. So kindly click on the subscription button as I bring you the next video. I will explain more of solar system. I know you are enjoying it. Never forget to recommend this video to someone else so that we keep on building the community and everyone will be happy to stay with. See you in my next video. See you.